Okay, today we're talking about special functions and whether or not you can graph and write a piecewise function. So, a piecewise function is a function defined by two or more equations. As you can see on our first example, there are two equations here. One is y equals negative x minus 4 and one is y equals x. They have stipulations though. So y equals negative x minus 4 only when x is less than 0. So I'm going to graph negative 4 and then down, up one, left one to get my negative slope. And then I can also graph y equals x, but that's only when x is greater than 0. So I would start at 0 and go up 1 over 1. And there are my two lines. Now, this first equation says x is less than 0. So I have to have an open dot on the negative 4 because x doesn't actually equal that 0. So the negative 4 has to have an open dot. But because of this equal sign here, I have a closed dot on y equals x, the graph of y equals x. So to graph each piece of our piecewise function, all we do is we take the two pieces, y equals negative x minus 4 for x is less than 0, and y equals x for x is greater than or equal to 0. Alright, so the next thing we have to do is describe the domain and the range. So you'll remember that the domain is your x's and the range is your y values. So looking at the graph, we can see that the x values, so we have, here's all my x values. This is going on forever in this direction, this line. This line is going on forever in this direction. And they overlap at 0. Because of that, our domain is going to be all real numbers. There's no break in the domain. That it continues on. All of the x values will be in the domain. The range, on the other hand, starts here at negative 4, and these go on forever in the positive direction, these go on forever in the positive direction, but I have nothing going down in the negative direction. So my range is going to be y is greater than negative 4. It's greater because, and not equal to, because this is an open dot, so it's not got an equal sign. And negative 4 and above is where all of my y values will be. There's nothing going below that ever in these two equations that we have, or in this piecewise function that we have. Alright, if you guys look at the next problem on your page, I totally messed up these notes. Deepest apologies. So I'm going to erase all of this and just do the next one. Oh, that's my baby sneezing. I'm just gonna do the next problem that's on your page right here on this same graph that is right here. So the next one says y equals x plus 3 if x is less than or equal to 0. So to graph that, I start at 3. to graph that, I start at 3. And I'm going up 1 over 1 or down 1 left 1 since it's less than or equal to 0. And since it's equal, I have a closed dot. Then I have y equals negative x if x is greater than 0. So that starts at 0. There's no equal sign here, so I have an open dot. I'm going when I graph this, I'm going down 1, right 1. So this is what my piecewise function looks like. And then I have to describe the domain and the range. So the domain, again, we're looking at the x values. And if we're looking straight across, these are going forever in the negative direction. These are going forever in the positive direction. So my domain is all real numbers. And then my range is going in the negative direction. Both my functions, or both of my rays, are going in the negative direction. So the very biggest number that I have is y equals 3. And y is always going to be less than 3 because all of these are going to work, but nothing up here is going to work because these are going down and down. So y is less than or equal to 3 because there's a closed dot on the 3. So I want you to try the next 2 problems there. I think you should be able to do the 2 piecewise functions and identify the domain and the range. The next thing that we have to do is write a piecewise function given a graph. So when you're looking at your graph, go ahead and turn to the next page. I know it doesn't look like mine, but when you're looking at the graph on your page, this first one is an open dot at 3, and it's decreasing. And the second one is a closed dot at 1, and it's increasing. Okay, so we have to write the function. So we can say y equals, and so let's take a look at this first one at positive 3. And the slope of that is up 1 over 1, so 1x plus 3, or just x plus 3. This second one starts at negative 1, and its slope is up 2 over 1, so 2x minus 1. Now we do have to write this part, this if part. And for this first one, we're only doing x's that are negative. So x has to be less than 0. And for the second part, we're doing x's that are positive, x is greater than 0. Then we have to identify if we have an x. Then we have to identify if we have an equal sign or not. And we have an equal sign on the second equation because it has a closed dot, and not on the first equation because it has an open dot. So that's how you write a piecewise function given a graph. I know the next thing on your notes is what is a step function. And a step function is a piecewise function It's a piecewise function defined by constant values. These are always going to be line segments. So the step function that I talk about on your notes is a karaoke machine problem. It says you rent a karaoke machine for 5 days. The rental company charges $50 for the first day and $25 for each additional day. Write and graph a step function that represents the relationship between the number of days X and the total cost of renting the karaoke machine. So on this, we have, so if we rent the karaoke machine for 0 days, or like, what about if we rent the karaoke machine for a half a day? Well, the problem says $50 for the first day. So whether you only keep it for the first day or for only half a day or 3/4 of a day or whatever, for 1 day it's going to cost you $50. So if our rental is between and all the way up to 1 full day, so anything less than 1 day, more than 0 days, all the way up to equaling 1 full day, will give us a $50 price tag. And then we can do this every time. So anything that's even just the tiniest bit above 1 day, so 1 day and 1 hour, all the way up to 2 full days, gives us a $75 price tag. And so on and so forth. All the way up. There are as many ways as you would like to put on your graph. Now you have a nice neat graph already there for you. I'm going to try to replicate. But there should be 150. So when we go to graph this, 0, anything between more than 0 and up to 1 is going to be $50. Anything above 1 and up to 2 is going to be $75. Above 2 and up to 3 is $100. Above 3 and up to 4 is $125. And above 4 and up to 5 is $150. So you can see why it's called a step function, because it looks like a set of stairs and increases at regular intervals. Okay, I think the next thing that you have are absolute value functions. And absolute value functions are obviously when we have an absolute value. it has a V-shaped graph that opens up or down. And the most basic absolute value function would be the function absolute value of x. And that looks like on the graph, it hits here at 0, 0, because if you put in 0 for x, you're going to get 0 out. And then it looks like this. Because if I put in -1 for x, it's going to actually equal 1. If I put in +1 for x, it's going to come out to equal 1. The absolute value of -1 is 1. The absolute value of 1 is 1. The absolute value of -2 is 2. The absolute value of 2 is 2. So you can see why your absolute value function looks the way that it does. I'm not sure what's on the absolute value page of your notes. I think it may be y equals the absolute value of x plus 3. All that happens whenever you have the absolute value of x plus or minus any number is that moves it up or down on the y-axis. So in this case, we're going to have a y-intercept of 3, which this is still the y-intercept, right? It still looks the same as every other y-intercept. And then it's going to be increasing just like the original absolute value equation. If you can't remember that, the best thing to do for an absolute value equation is to make a table. So if we make a table of values, if x is -2, I would fill in -2. The absolute value of -2 is 2. 2 plus 3 is 5. If x is -1, the absolute value of -1 is 1 plus 3 is 4. If the absolute value of 0 is 0, 0 plus 3 is 3. The absolute value of 1 is 1 plus 3 is 4. The absolute value of 2 is 2 plus 3 is 5. So you could graph these points on the line to get your values. So let's look at another one. If we have y equals the absolute value of x minus 2, we're definitely going to have to make a table of values for this one. So I have x values and y values. So I fill in -1, 0, 1, 2. That's probably good enough. I'll be able to see. You are always going to want to do some negatives and some positives, though. It'll probably help you see what's going on. You also may have to extend this and do different numbers, or even skip around. Like if you wanted to do -1, 2, 5, and 7, that would be fine as well. So -1 minus 2 is -3. The absolute value of -3 is 3. 2 minus 2 is 0. The absolute value of 0 is 0. 5 minus 2 is 3. The absolute value of 3 is 3. 7 minus 2 is 5. The absolute value of 5 is 5. So if I graph these, -1, 1, 2, 3, 2, 0, oops, 2, 0, 3, 4, 5, 3. So you can see that your absolute value equation is looking like this. this very last page. Oh yeah. So we'll do this one together. Sorry about the mess up. Y equals 1/2 absolute value of x. Compare the graph to the graph of y equals absolute value of x. Describe the domain and range. So we want to make a table. And I might choose -2, 0, 2. See what happens on those three numbers. So fill in the absolute value of -2. Half of 2. The absolute value of -2 is 2. So half of 2 is 1. Half of 0 is 0. Half of 2 is 1. So -2, 1. 0, 0. 2, 1. So it looks like it's going to be a wider V here than our normal. Oh wait, that's supposed to be negative. So these should be negative. It's a -1/2. That was my bad. So we should have -2, -1. 0, 0, 2, -1. So it's a wider V that we're getting compared to our normal absolute value, which looks like this. So if we're going to compare the two, all I would say is this one opens down and is wider. And then the domain and the range of this. So the domain is all real numbers because this goes in this direction, this goes in this direction. But the range is going to be y is less than or equal to 0. So it should be anything less than or equal to 0. Okay, I hope I got everything in to make these notes work for you guys. Go ahead and try 8, 9, 10, and 11. See if you can get those on your own. Writing the piecewise functions. You may have to go back and look at the example that we did. Yeah, have a great day.